Hi everyone, today we are going to talk about Taylor series and we will just try to prove the formula for Taylor series with one variable. Let's just write the general formula and then try to prove it. General formula for Taylor series approximation is written this way and starts from 0 to infinity. F0 to the power n to multiply by x to the power n divided by n factorial. And this is our function, and mainly while trying to prove this approximation the polynomial function is used, which is in the form of a0 plus a1x plus a2x squared, and this way and at the end an x to the power n. And we can try to write this formula in terms of the terms, the one by one. Let's write it for the first term of this general sum. F0, when the n is 0, it means that we don't need to find the derivative of this function multiplied by x to the power 0 divided by 0 factorial, which is equal to 1 plus f0. This means that we should write here 1 dash, which means to find the first order derivative of this function at point 0 multiplied by x to the power 1, which is equal to x divided by 1 factorial. And let's write it for other two terms and try to analyze it, because to prove this theorem the mainly intuition is used, and it is called that this theorem is intuitively proven. And let's write it for another two terms. Double dash x to the power 2 divided by 2 factorial plus f0 triple dash x cubed divided by 3 factorial, and this continues the same way. And here we should just replace these terms to prove this theorem with in terms of the derivatives of the function at point 0. And how we can do this? When you can see that when f at function f, when x equal to 0, let's write it f0, the function is equal to a0. But when we think in terms of a1, how can we just derive a1 from this function? Thinking a little bit, we can see that f derivative of x in first order will be equal to, of course, that with respect to x. Well, a1 is constant term, therefore it will be cancelled out, and then a1 plus 2a2x plus it will continue, and n will come here, and an x to the power n minus 1. And here we got the a1 term just separately from x variable. And if we just replace here x with 0 and get the value of function, we will find that all the terms with x variable will be removed, and we will just be left with a1. And also for other terms, other just constants here, we can repeat this process, finding the double the two derivative of this function. We will get the derivative. We need to find the derivative of this function here. a1 will be cancelled out again because it's constant, and x to the power 1, we will remove x here, plus if we just write here the another term, example a3 x cubed, its derivative will be here 3a3 x squared, and when we find the derivative of this term again with respect to x, it will be 6 a3 x. I think when you see 2 6, you kind of see that this is the order of the factorials. 2 factorial, 3 factorial, as you see in our equation. And let's write for the third term to see that whether this is as what we just claim here or not. Let's come starting from the first order derivative, the plus a4 x to the power 4, and when we find derivative it will be 4 a4 x to the power 3, again finding derivative 12 a4 x to the power 2, and when we find derivative here, this will be cancelled out and this will left with this one, 6a3 plus 24 a4 x. And we see that our suggestion was correct, and we just found that all the coefficients in this polynomial function can be replaced using the derivatives of this f function at point 0. For example, f triple dash 0 will be equal to here it will be equal to 6a3, and for the another one, the fourth order, it will be equal to 24, and it will continue as the same way for another order derivatives. And let's try to write our final formula in terms of what we found here. Let me change the color of this pen and write our final suggestion here. And let's write what we have here. A0. What is A0? A0 is equal to f0 without any derivative, f0, and here it can be written as x to the power 0 divided by 0 factorial. This is also equal to f0. And this, why did we write this term here? You can ask me. But in order to find it, we should go through the another terms of this, the final formula. Let's write it for second term. For second term, we should write a1. What is a1? a1 is f derivative 0, f derivative 0, x to the power 1, as you see here. We have 1x x coefficient, 1x variable here is the power of 1, and it will be divided also with 1 factorial. You see that here it is 0, it should be 0, 1, it should be 1. And for the third term, how can we find it? It will be 2 dash f0, which will be equal to, these terms will go, 2a2. And in order to write a2, we should divide it by 2 factorial, coefficient of a2. F double dash 0 x to the power 2. To get only the a2 coefficient, we should divide it by 2 factorial. It is the same as what we expected, 1, 1, and again 2, 2. This trend will continue till the end. The next term will be 3 dash 0 x to the power 3 divided by 6 equal to 3 factorial. And we got the final formula, and these terms will continue till infinity when fn 0 x to the power n divided by n factorial will be our last term. The n here represents the infinity, and f to the power n 0 means that we should find the derivative of fx function n times with respect to x, then write 0 to the places of where we see x, and we get the result of this function here you see. And this is the end of video. Thanks for watching. If you liked and could learn something, please like, comment and subscribe to my YouTube channel.